Okay. So, yeah, linear just means it's a line. Which on a picture, that's easy enough to tell. But when it's not a picture, we need some tools to be able to get there. So the way we define this is it's got no variable. So X or Y or any other letter, and that is meant to be an E. Let me fix that.
The teachers at this time, all freshmen, 9th grade students, all freshmen, need to make your way to the Performing Arts Center auditorium. Teachers, go with your students. Teachers, go with your students to the auditorium. Freshmen at this time, get to the auditorium. Bring your belongings. Bring your belongings. We'll dismiss from the auditorium. Teachers, if you have mixed classes, go with the majority of your students. Everybody goes with you if you have mixed. If you only have a few freshmen, send the freshmen on their own. Again, freshmen, get to the auditorium quickly.
Okay, so the way we can tell from an equation is that it has no variable. Remember, a variable, that's our letters. So it's this letter. With a power or exponent, the little numbers of pi, other than 1. If it is anything other than 1, it's not linear. And we have two different forms for our linear equations. We can write it in slope-intercept form, which should hopefully be familiar. And our slope-intercept form, that's our y equals mx plus b. So if I can make it look like y equals mx plus b, it's a line. Or if I can get it into what we call general form or standard form. Oh, my O's don't like to look like O's today. Our general form, that's a number with the x plus a number with the y equals another number. So we call that ax plus by equals c. It's important here that all of these x's and y's don't have anything as their exponent. They have an invisible 1 there, because everything has an exponent of 1. We just don't write it because it makes stuff look real crazy if we do. But we don't have any other exponents there. If I can make it look like general form or like slope-intercept form, it's a line. If I can't make it do that, it's not a line. And at this point, that's all we're going to specify about it. It's not line. Line or not line. So when we're looking at nonlinear, all this means, non means not. So if it is not a line, it either has a variable other than 1, or the picture has curves. So on a picture, it's really easy to see line versus not line. It's ruler or wiggle. On your equations, it's more of a process of elimination. Equations need to be able to look like this, one of them. I'm going to give you a second to write that all down. But that's what we're going to focus on mostly today, is Is it a line or is it not a line? We might get into a couple other pieces in a little bit. But that's what we're starting with, okay? So we've got an equation here, and it's a weird looking one. This is going to introduce us to a couple of new pieces here. This guy looks a little crazy. This you saw in Algebra 1. You should have seen this. Function notation is what this is called. All this is y. The f parentheses x is y. He's just dressed up in a fancy suit. He's y. This whole chunk. So I could write this as y equals 6x minus 5 over 3. Those are twins. They are the exact same thing. More than that, they are clones. Just on my desk. Thank you, dear. Those two things mean the same. More often than not, we are going to use this for our y's because it is a proper mathematics thing, like it's a math grammar again. It genuinely doesn't really make a difference until you start getting into pre-cal stuff. Like it's really important in things like pre-cal. It's just grammar here for us. We're not, like, f of x is not really going to be a humongo deal. But we're going to see it a lot. We're going to use this a lot this year. So f of x is how we read that. F of x is y. So then we're going to look at the hard part of this equation is this guy a line? And I think the easiest way to do this is to say, all right, let's split that fraction up into pieces. And like not cross the equal sign, but we can start with seeing if I can get this to split into pieces. And I did not mean to do that, but that's okay. We're going to do that. There we go. So I could say, well, maybe y equals, and we'll split it in half. 6x over 3 minus 5 over 3. I'm unsimplifying it here to see if I can make it be slope-intercept form. Because slope-intercept form has an x and a y on each side. I want to look at each of these pieces and see if I can simplify this. Look at this guy. Can I simplify this piece at all?
Yes.
Yes. How?
Divided by 3 makes 2x.
Yeah. Y equals 2x minus, can I simplify this? Nope, but 5/3 is fine. It's a thing. We can do that. So then our big question is that slope-intercept form, or is it something else? And we're looking for either y equals mx plus b or ax plus by equals c. If I can make it look like one of those, it's a line. Does it look like one of those? I hear a mix, and that's okay. Because if we look down here, if I line it up next to each other, y equals mx plus b. Does it line up?
Yes.
Yeah, it does. We have a m of 2 and a b of what?
5/3.
Negative 5/3. Watch out for that. It's okay for there to be a minus sign. All it means is that we have a negative in there. So yes, I can make this. This is a linear equation. It looks weird up here, but it is linear. Questions on this one? You can make this also look like the standard form, but it's a lot more crossing of the equal sign. So see a few people writing. So I'm going to give you a couple more minutes to write, or a few more seconds to write. And we're going to do another one. We're going to see if the next one is linear, if it's a line, or if it's not a line. And it looks like this. Oh, I love it. It's different than I had in my notes, but that's okay. It's still the same thing. So is this a line or not a line? Remember, a line looks like either y equals mx plus b or ax plus by equals c. If it looks like one of those, it's a line. I've got an exponent on a variable. This guy. There's 2 on the top. I can't undo that. We can't move that. I can't get rid of that. This, ooh, that's way too skinny. Holy cow, I'll try that with that. So if we have an exponent, on a variable, then it is nonlinear. So this one we didn't even have to move stuff around. And it doesn't make any difference if that exponent's on my x or if we had an exponent on the y. It still means it's not a line. Questions on this one? Or on the last one? You guys good? You guys good? Okay. Okay. So let's look at these pictures. And you can just like sketch these. Like I didn't print these out as graphs. We are not reading anything off. It's just, is it a line or is it not a line? So this guy, is it a line? No. Non-linear. Ta-da, we did it. That's the extent we're using that curve for. It's why I didn't make a graph for you for that one. Is this one a line? Yeah. So it's linear. Yay! We did it. Once we are going to do a little bit more with it, but that's okay. We're still going to do it. So that's kind of the basis of linear versus nonlinear. I'm going to have 2 more vocab words for you here in just a second. Ooh, I do have one graph I should have printed and I didn't. Oh well. Okay, so we're going to be looking at x and y intercepts. Stop doing my notes right there. So an intercept is where it crosses. So an x-intercept is the point or points. I'm going to put the little parentheses S. So it could be more than one. At which the function crosses the x-axis. So the x-intercept is where it crosses the x-axis. Marker real quick. So we can think about a graph. I know it's going to be somewhere on this line. I'm going to get a value for x. My x-intercept can be 0, 3, 27, whatever. The one thing I know about it, if it is on my x-axis, is that my y value will equal 0. It's at height 0. It's going to be sideways somewhere, but it is at height 0. So our x-intercept always has a y of 0. The y-intercept is a very similar vibe. It's the point, and in this case there's only going to be one if it's a function. At which the function crosses the y-axis. So that's our vertical. It's going to be on this center line. My y is going to be some number. My y could be 1. My y could be 27, -4, -5/3. It doesn't matter where it is vertically. The one thing I know about a y-intercept is that my x value is 0. Okay, so get those written down. I remember what those. And those two little sketchy sketches we kind of sketched out on the last bit. We're going to think about those guys again. I probably should have printed these. Sorry, all my guinea pigs. First of the day. Because we're going to come read our x and y intercepts here. So x-intercept on this graph here, this left one, the curve, are nonlinear. X-intercept is where it crosses our x-axis. This guy's my x-axis right here. So where does it cross my x-axis? -1 and +4. So a lot of times I'll give you a homework assignment that has x-intercept and does something like this. We can say it's at -1. And I'm just going to write it out. 4. Or you can do the ordered pairs where it's my x is -1, my y is 0. And I'll do the squiggly one. 4, 0. Give myself none space to write on this screen, and I love that for me. So much fun. None space. Yes, my friend.
But you can just put -1 and -4. I mean.
Yes, just don't put, because this is the most common mistake. I'm going to say don't write this. -1, 4. Okay, so don't blend the two. Because so don't write that down. -1, 4 is this guy here. This is not my x-intercept. So don't smash the ideas together. Either do separate or do points. Don't try and take a shortcut and do one single point, because now it's no longer the right point. Where is my y-intercept on this graph? -2. Let's put it down at the bottom. And again, I'm fine. What was that? I'm fine with you putting -2. Or we can put the whole point of 0, -2. Yeah. Because these are intercepts is the only reason we can just put a value, because it's less than an x-intercept has a y value of 0. We know it. It's part of the definition of an x-intercept. So we can shortcut. So let's do x-intercept on y-intercept on our line. The linear guy. What is our x-intercept? 4. So let's go 4, 0. That's my intercept. And I'm just going to put x-int. X-intercept. Because I gave myself none space to write, because I planned ahead. What's our y-intercept? -2. They have the same y-intercept. 0, -2. Even have the same x-intercept a little bit. One is the same, so it makes a difference. You got to make sure you get them all. Okay? When we get into like homework stuff, we're going to see some real squiggly ones. Same process. On ones like this, especially that we pull out of the book, be super extra careful. They love to count by weird numbers. The x's, they counted by ones. And I can fill it in. 1, 2, 3. -1, -2, -3, 4. The y's, they counted by 4s because they're jerks. 4, 8, 12. They're jerks. The book makes choices like that. I don't know why. It's a choice. Is the only answer I got for that. So just be careful, okay? So make sure you're watching for those. So we're just going to estimate these. We can just do these together. You got to be like super specific on a sketch on this one. I'll get you homework with good pictures. I promise. So where are the x-intercepts on this one? Yeah. -3. -1, and 2. Yes, you're exactly right. I don't know why I put a comma there. X-intercepts are -3, -1, and 2. How about y-intercept? It's at 12. And it said estimate, so it doesn't matter if it's 12.2 or whatever. What's going on with my pen right now? It's being a jerk. Okay, so that's all we're doing when we're estimating x and y intercepts. We have one last piece. I want to show you. Sometimes we're going to have story problems. Oh no. We got Ricardo launching a rocket from a balcony. And he had a little GPS tracker on his rocket because he's extra. And then he recorded the heights at each second of flight. And his rocket flew for 8 seconds. That's a really high rocket. Or at least a very slow rocket. So what we need to be able to do is we are going to look at this table and find our x and y intercepts. Important thing to know on tables, your time is always going to be your x. So time is x because I can look at different times. I cannot, and I can change the number of times. I can say, well, it started at 2 seconds, or it's 5 seconds when it launched. I can't say, well, I'm going to put it at 20 feet and make it time travel back in time. I cannot change its height and make time change. I can change the time and make its height change. But I cannot physically move the thingy and make it change time. Because we can't change time. So time is always going to be our x. Always. Process of elimination, that means height is our y. How do I find my x-intercept without a picture? Remember what our x-intercept has? The y is 0. So where is y 0? The bottom one at 8. So this guy is my x-intercept. Whoops, that's not a pen. So x-intercept is at 8, comma, 0. This is when sometimes it helps to write it as points. My y is 0. That's how I know that. What does that mean? What does that 0 mean, thinking about this problem? It's 0 what? 0 feet. What does it mean when my rocket's at 0 feet? It's back on the ground. So my x-intercept is when it lands. How about my y-intercept? Where's that? The 0, 15. It's when my x is 0. Zero, 15. What does that represent? What does that mean? How high was it takeoff? My platform's 15 feet in the air. So it is how high it is at launch or at time 0. So I got the word launch from here. Okay. So when it says what does it represent, use our labels. How high it is at launch or at time 0. What time when it hits ground, when height is 0. So if you get stuck on context things, use our labels. Okay? I will put it back on that. I was just making sure I was on the last page. So we have more things we're going to talk about. A lot of the times we're going to have 2 days for each lesson. So I have another worksheet for you. Yay. And you guys can do all of the front page and the first 2 on the back. And then tomorrow we will talk about the last 2 pieces on here, okay? So you guys have 10 minutes till announcements to work on this. And then you also do not have to turn it in today. We are going to talk about the last 2 things tomorrow, so don't try and like force it to finish because we're not there yet. We have to talk about 2 more things. But again, it is these questions. These are questions 1 through 6, 11, 15, 16, 18, 22, and 23, or 33, from pages 19 and 22. It's the same exact questions. I just printed it out so you could scribble on it. Again, I'm going to point out, watch out on the graphs where they have numbers. They sometimes count weird. The ones where they don't have numbers, you can assume they're counting by 1. But if they've got numbers, pay attention to them. Okay? Make sure you turn in homework 1 that is due today. And then you guys can get started on this, and that's all I got for you today. Excuse me. The turn-in bin is on the silver shelf right by the door. It's on the second shelf. Yes, I'm going to pass.